Hi everyone, today we will discuss about experiment 12 of analytical chemistry, which is gravimetric analysis phosphorus in plant food. This is our members. We have Asma Suaida binti Makalid and Nur Emilia binti Muhammad Akhir. This is our agenda for this experiment.
Okay, our objective for this experiment is to determine the percentage of phosphorus in a plant food through the technique of a gravimetric analysis.
Okay, now let's look at for the method. First, we have to prepare all the apparatus first. Obtain your plant food sample information and then record all the information written on the label. Weigh 3.6 gram of plant sample and transfer the sample to a 250 ml beaker. Add 40 ml of distilled water and stir the mixture. If the sample does not dissolve, remove the insoluble material through filtration. To filtrate, add 50 ml of 10% of magnesium sulfate heptahydrate. Then, add 100 ml 2 molar of ammonia and stir. White precipitate of ammonium magnesium phosphate hexahydrate form. Allow the mixture to sit at the room temperature for 10 minutes.
Cut and feed the paper in the Bunsen funnel. Weight accurately the filter paper. Wet the paper with distilled water to hold it in place in the funnel. Then, set up the pump to the Bunsen flask. Transfer the precipitate slowly and all the solution from the beaker onto the filter paper. Next, measure 5 ml of distilled water to wash the precipitate for 2-3 times. Rinse again the precipitate with 2 10 ml of 75% of isopropyl alcohol. Remove the paper and place it on evaporating dish. Store it to dry for 2 or 3 days in the oven for 24 hours at 60 degrees Celsius. When the white precipitate is dry, weight the filter paper plus the precipitate. Lastly, record the mass and calculate the percent of phosphorus in your original sample. Based on the experiment we had, we used budget special green as a plant food sample. The percent of phosphorus writing on the table is 15%. The mass that we used in this experiment is 3.5 gram of sample. From the experiment, we obtained that the mass of filter paper with the precipitate is 1.8042 gram, and the mass of filter paper itself is 0.4661 gram. So, we get the mass of precipitate is 1.3381 gram. Next, we go to the calculation. First, we have to calculate the mole of phosphorus based on gravimetric analysis and mass of precipitate. To calculate this, we have to know the molar mass of precipitate first. So, we refer to the periodic table to calculate it. We gain that the molar mass of precipitate is 137.24 gram. From that, we use it to calculate gravimetric factor. The formula of gravimetric factor is molar mass of phosphorus is divided by molar mass of precipitate and times with the ratio of element, where 30.97 is divided by 137.24 and times with 1/1. We get 0.226. Then calculate weight of analyte, where we time the weight, precipitate and gravimetric factor. So 1.3381 gram times with 0.226 and we get 0.302 gram. Lastly, we calculate the mole with mass divide molar mass of phosphorus with 0.302 divided by 30.97, which result is 9.75 times 10 negative 3 mole. To calculate mole of phosphorus pentoxide, we use same technique like the first question. We calculate first the molar mass of phosphorus pentoxide, where we get 141.89. Then we calculate the gravimetric factor with the molar mass of phosphorus pentoxide divided by molar mass of precipitate and times with the ratio of the element. 141.89 divided by 127.24 and times with 2/1 and we get 0.517. After that, we calculate mass of analyte with 1.2381 times with 0.517, where we obtain 0.962 gram. Next, calculate the mole with the mass divided by molar mass of phosphorus pentoxide, where 0.962 divided by 141.89 and we get 4.88 times 10 negative 3 mole. Next, second question, we have to calculate the mass and the content percent of phosphorus pentoxide in the sample. First, we calculate the mass with mole times molar mass of phosphorus pentoxide. 4.88 times 10 negative 3 times 141.89 and we get 0.962 gram. Next, the content percent we calculate by using formula of weight of analyte divided by weight of sample and time 100. So 0.962 divided by 3.5 and time with 100 and we obtain 19 and 77% of phosphorus pentoxide that present in the sample. Lastly, we have to calculate the percentage error of the experiment. For this calculation, we use this formula. We calculated value minus true value, then divide by true value and time with 100. True value is obtained by the sample, which is 50% of phosphorus. So 19.77 minus 15 and divide by 15, then times 100 to get 31.8% of error.
It was determined that the percentage of phosphorus is 50% and phosphorus pentoxide is 90.77%. It was calculated that the percent error of the two percentage is 31.8%. Ammonia is gradually added to the solution while constantly stirring to ensure that formation of the precipitate, resulting in a precipitate that is easy to filter and free of the impurities. To to ensure the proper production crystals required by the experiment, a state technique of adding precipitating agent such as dropwise additions or a certain amount per second or stirring might be used. The mixture has to be covered to prevent the impurities from entering the air while it is being digested or allowed to stand still. To summarize all that has been said thus far, the experiment's goals has been achieved. It was found that the plant food contained of 19.77% of phosphorus pentoxide and 50% of phosphorus.